In this screencast, I'm going to show you a few of the tools in this Lasers applet from PhET, but I'm not going to explain why anything works. That's going to be up to you in your screencasts to come. You'll notice there are two tabs, one atom, absorption and emission, and then the multiple atoms, lasing. In the one atom one, just like it says, it's for understanding absorption and emission, and you probably won't actually get lasing to happen or into the danger range. Okay. In order to do this, you can adjust the lamp control. Okay. Changes the amount of photons coming out of the lamp. You can change the energy level of the atom. So I can move this second level up. That's the first excited state. And you'll notice if I do that, my red line here, the squiggly line, doesn't reach all the way up to the next energy level. That means that the energy of these photons coming out, these red balls, doesn't match with the energy level of the electrons inside this atom that's number 1 here. In order to change that, I can adjust down here the colored slider. You can see that on the top right hand side, the level of the photon energy is changing. So I can line that up so that it matches up to the energy level, and then we can get some excitations happening. Okay, you see the gray ball here. This is representing the electron changing from one level to the other. We have a lifetime, which indicates how long the electron is going to stay. So if I lower it, it should change even faster. Okay. If I increase it, it takes a little bit longer to change in between the levels. So we can see down here in the box, the internal power is going, but we're not getting into the lasing range and certainly nowhere near the danger range. And we don't have any output level. You can change to 3 energy levels and make adjustments, so you'll have a second lamp that can provide more energy, more photons. Okay. You can enable mirrors. You can see what the mirrors do. You can change the reflectivity of the mirrors so you can still get some coming out of this one on the right hand side. Okay? You can imagine if this tube is meant to represent a laser, then you're going to need them to come out at this end to some degree, but you're still going to want some reflectivity so you can get some bouncing back and forth. Okay. Other things you can do, you can view a picture of an actual laser, so you can see how it works, and there's a write-up here, see how it looks rather. How it works you're going to have to investigate. And you can click the help button and it gives you some helpful text in different areas. So going over to the multiple atoms, it's similar, but not exactly the same. You adjust the lamp control. This time it shows as a beam to start off with, but I can adjust over here into photons. It looks kind of crazy, so I'll put it back to beam right now. You can have 2 or 3 energy levels. You can enable mirrors like before and adjust the reflectivity. You can display photons emitted from the upper energy state. There they are. Okay. You can change from the lower transition to be wave view instead of photons. Okay. In order to get lasing, a good strategy to follow is to have a long lifetime on the first excited state, which is the second level here, and a short lifetime on the top one. Okay. I want to put some mirrors on with a high reflectivity, but not 100. And you can see already I'm getting into lasing here. You can see the lasing looking a little bit better if you change it to wave view, and it looks a little bit more like a laser is going on. But of course, if you change it back to photons, you can look at the way the photons are distributed to get the same effect as what the wave view is showing. It's not quite so easy to see. Okay. So you're to use this applet to address the assessment statements that are mentioned in the forum. And then you take your screencast, as mentioned in the forum, and post it into a discussion to start things off. Okay, happy hunting!